Good morning all. In this video and a few other videos subsequently, we'll have a short discussion on well foundations. Now, well foundation is a deep foundation. Nonetheless, it's a foundation which is used to transfer the load from the superstructure to the soil. Well foundations are quite common for bridges. Now, you must have traveled the stretch between Trivandrum and Kasaragod, and somewhere down the line you may have passed through a rail bridge, right? A rail bridge is usually supported either by well foundations or by pile foundations. Now, what you see in this particular picture is a rail bridge below which it's supported by a pier, and beneath that pier you can expect a well foundation. Now, well foundation, as the name suggests, has got its resemblance with a well. It's big, it's circular, and it's deep. So the well foundation is a huge structure by its scale compared to the usual structures that we see around as foundations, and it is used to have a greater load transmission, which means it's transferring the load to a greater area, and of course it can transfer a heavy load as well. So that's why we used to choose this well foundation for bridge structures. Now, the elements of a well foundation is shown in this schematic picture. Now, it has, like you can see in this figure, the photograph, there's a bridge below which there's a pier, and that pier is shown in this picture over the top. So whatever that comes below the pier is a well foundation. Of course, when you travel by the road or by rail, you may not be able to visually inspect the well foundation because it's beneath the soil level. So below the pier you have an RCC slab, which is called as a well cap, and then you have a top plug, which is usually a concrete plug or a concrete mass, and below which you have the wall of the well, which is called as a steining, and beneath which you have what is called a curb, and at the bottommost level you have what is called as a cutting edge. Now, there's another bottom plug at the bottom, just like the top plug, which conceals the cavity within it. Now, this cavity can either remain as such or can be filled with sand. You are left with the two options depending on the lateral load acting on the well foundation and whether you want to resist the lateral loads using the weight of the well. You'll have to fill it with sand. So that's a cross section of a well foundation, and the first element is a cutting edge, the one that you see to the bottom. Then you have a curb on top of it. Then you have the bottom plug. Then you have the well steining or the wall of the well, and then you have the top plug, and then you have the well cap. Now, above the well cap you cast the pier, and above the pier you have the superstructure, the bridge usually. Now, this picture would probably give you a better understanding. You have the pier there, you have the well cap, below which you have the top plug, then comes the steining. You can have either the cavity filled with sand or you can leave it as such, and then you have the curb here, then you have the cutting edge and the bottom plug. Now, we'll start with the cutting edge. The cutting edge is nothing but a sharp edge iron angle. Now, the fundamental use of this is to penetrate the well into the soil substructure. So the construction process of a well is called a sinking of well. You have the cutting edge placed over the sand layer, and you are kind of jacking the cutting edge deeper and deeper into the soil and simultaneously constructing the well upward. So it's kind of jacking in the entire structure into the soil. So that process is called as a sinking of the well. So the cutting edge role is to enable the easy penetration or the sinking of the well. And for the same reason, it should be structurally strong. It should be able to take the stresses acting on it. So that's a brief explanation of what a cutting edge is. Then you have the curb which comes above the cutting edge, is kind of a transition member between the cutting edge that we have installed and the well steening which we are about to install. So this curb acts as a transition member to transfer the load between the cutting edge and the steening of the wall, the steening of the well. So it is usually an RCC body and has a tapered geometry, as you can see in the picture. And during installation, it's subjected to huge stress. Of course, we can imagine now the diameter of this the well foundation. You may get a flavor of the dimension from this photograph. It can be around 5 meters in diameter. It can go up to 15 meters in diameter, depending on the load that you're about to transfer. So it's a huge structure. So the huge structure is taking a huge load from the superstructure and with its self-weight in addition. So the curb should be designed to have a safe carrying capacity of the huge stress of the dead load and the loads generated during the installation. So that's a curb. And then you have the bottom plug. Now the bottom plug, like I said, is a concrete plug at the bottom, and it acts as a seal at the base of the structure, and by which the load gets distributed over a larger area. Had it been just the cutting edge, the stress will be concentrated there. So once you have plugged it using a concrete, it will act to distribute the load to a greater area and thereby reducing the stress within the safer limits. Now, in cases where the well foundation is rested on rock, you do have the option to avoid the concrete plug because the rock itself will be safe enough to carry the load. Then you have the steening, or the well has a steening, which is nothing but the wall of the well. So it forms a body, and it's usually RCC, reinforced cement concrete, or at times brick masonry or PCC, depending on the case. And it's constructed in stages or lifts. Let's say 1.5 meter height is one lift, and it's constructed in stages of 1.5 meters. So again, like I said, a typical example of a well foundation is a diameter of, let's say, 5 meters and the depth of around, let's say, 12-15 meters. So that's just my trial to give you a sense of dimension about how big this structure is. Now then you have what is called as a top plug. Again, it's a concrete body. Now after construction of this well, the well steening, once you have installed the well steening up to a depth of, let's say, 12 meter or 15 meter, which is the design depth, obviously there's a cavity formed inside it because you dredge the soil out of it while trying to sink it down. So I'll give you a detailed explanation of how the process of sinking is after we discuss the portions of the components of the well. Nonetheless, after the well is sunk, the cavity inside that, which is nothing but a dredge hole, could be filled with sand. Like I said, it increases the rigidity and thereby the resistance against the lateral load. And the layer of concrete placed over the filling is called as a top plug. It increases the stiffness of the well and helps to distribute the load from the superstructure. So that's a function of a top plug. Then you have finally the well cap, which is between the pier, which you see above the ground level, and the well steening. So it's between the pier and the well steening, and it transmits the load uniformly onto the well foundation. So these are briefly the components of a well foundation. And like I said, the well foundations are usually in practice for bridges and heavy structures. We'll discuss the problems of sinking, the procedure of sinking, and certain other executional errors that may creep in during the sinking process in subsequent videos.